Hello, it's Keith here, and this is lesson 2 of the Simple series of my ARM assembly programming tutorials. What's the Simple series? Well, every time we do this, we create a single assembly file that does a task, and it's self-contained, so if you're getting started and if you're not using the same assembler as I am, hopefully it's going to be a bit easier for you to convert and get started with. Today, I think it's a really great one. We're looking at how to make a simple 8x8 sprite on the screen, a smiley in this case, and we are reading in from the Joypad, and we can move it around. So you can see we can move our smiley around the screen, but we can't go off the screen because we've got some boundary checking going on there. Now the idea is this could be a starting point for a little Pong game or some kind of shooter, but as I say, it's really just you need to get started, you need to read input, you need to draw graphics. Well, here it all is all in one, hopefully easy assemblable demonstration. So that's what we're going to be looking at. Well, let's go over to the source code. Let's take a peek at what we've got. Okay, you can see my message up there saying all source code available for download from my website, which is definitely true. I do get people commenting on this, not liking the screenshots on the website and saying they can't copy paste it. You shouldn't need to copy paste anything, you can download it all. So please do that and make use of it, that's what it's there for. Okay, so we're going to go over this file. We're going to discuss each section pretty quickly. So the start you can see here is at this address here. I think that's 8 million there, lots of zeros, I'm messing my eyes up. So that's the start of our program if we're creating a Gameboy Rom, but you can see that there's an immediate branch here all the way down to the actual start of our code here, and what we've got here is a nice juicy header. This is actually you can pretty much fill this all with zeros. The emulators don't really check it, but I've tried to make this correct. Hopefully it is, but basically you can leave this as is, you don't need to change anything in it. Now at the start here we're defining a stack pointer, because otherwise there wouldn't be one and our jumps wouldn't work very well, our branch and links wouldn't work. So we're defining one at the top of the RAM area here at 3 million there. We're then turning on our screen. Now the way we do that is we send this hexadecimal 403 to memory address 4 million here, and that turns on a bitmap screen. So this isn't tile and sprite, this is bitmap, which I think is easiest. We just write bytes to the screen memory area and they appear as pixels. I find that really nice, so that's what we're doing here. And the pixels we've got, you can see down here. So this is our sprite, this is a smiley. You might not be able to see the smiley, but maybe if you look at these 8000s and imagine those are black pixels, you can kind of see a circle here at least. Now these are 16 bits per pixel, or 15 sort of. We've got 5 bits per color channel here, so you've got 5 red bits, 5 green bits, 5 blue bits, and 1 alpha bit. Now I think maybe the alpha bit isn't used in the screen mode, but it is on the almost identical in Nintendo DS. So we've got it set to 1 here, the top alpha bit here. But basically you could, if you want, create this as byte data as I have here as sort of text. Now Word on ARM VASM in this STD mode at least is actually 16 bits. Now Word on ARM should be 32. I actually prefer this because I'm used to 8-bit systems, which Word is 16 bits, but I know it's technically incorrect, so just bear with me on that one. But if you want to create your own file and import it as a binary, which is a great thing to do, you can do it with my Sprites Editor, which is free and open source. If you go to ARM here and Gameboy Advance, or you could do NDS, because as I say, they are the same. And we've got some save raw options, save raw 256 color, not that one, it's this one, this 32,768 color, which option you want here, and that will save the file that you can actually see being used today. I just converted it to text here, I've got another program. Again, I wanted it all to be one file, nice and easy for you to convert, so I actually converted it to text, and that's the smiley that you can see here. So that's what we're using. Now, when it comes to showing that sprite, we've got a routine here called show sprite. Now, this uses a sprite format which is known as an XOR sprite. Maybe it should be called an EOR sprite on the ARM because of the command, but basically this uses the exclusive OR, and this will flip the colours of the existing screen pixels. So it will take the sprite, it will take the screen pixels and EOR them together. And the effect of this is if we draw our smiley on black pixels, it will look normal. But if we draw our smiley over an existing smiley, it will remove the first one, completely taking it away. This could be quite ugly if we've got lots of graphics on the screen, but for a very simple getting started example, it has the benefit of we draw the sprite twice, we've taken the first one away. So really easy way of getting started with some graphics and removing graphics and drawing them again. So that's why I'm using it here. Now we need to calculate taking an XY position and working out the screen memory pixel of that XY position, and that's what we're doing at the start here. Our VRAM base is at 6 million, so any byte we write to that area onwards is going to be appearing on the screen in some capacity. There are 2 bytes per pixel, so we take the X position, which is in R8, and we multiply that by 2. We then effectively take the width of the screen, which is 240 pixels multiplied by 2, and we multiply that by the Y line we want. So we're taking the width in bytes of each line multiplied by the Y line, and we're adding that with our X position to the screen base, and this calculates the pixel position in memory that we want to change. So what we're going to do next is get the address of our sprite here, and we're going to start transferring all of the bytes from the sprite EORed or XORed with the screen bytes and then written back to the screen, and that is this effect where if we write twice we'll remove it, and that's what we're doing here. Now we have to work in half 16-bit or 32-bit here, because if we work in bytes things get a bit weird on the Game Boy Advance screen, so we're doing that there. EORing the current screen byte and storing back. We're then repeating until our line is done. We're 8 pixels wide here because our smiley is 8 pixels wide, and then we're adding 240 times 2, which is one line, moving down a line, and we're repeating for the next line, and we're doing that for the 8 lines of our smiley. So that is drawn as smiley every time we run this show sprite. And you can see we run our show sprite at the start here. We got our starting position here, 10, 10. We show the sprite here, and then what we're going to do is we're going to read in from the Joypad. Now, reading in from the Joypad is surprisingly easy. We just read in from this memory address here, 4,130 here in hexadecimal. That is the Joypad on the Game Boy Advance. It's actually also the same Joypad, I mean the fire buttons as well as shoulder buttons and things like that. So we've got that there, and we are testing these 4 here, which are the directions. So we're just masking these, and we're going to test those directions and see if any of them are pressed, and if none of them are pressed we're just going to wait until they are. We're just in a loop here to wait for a key to be pressed, and when a key is pressed we're going to spring into action, so to speak. First we show the sprite again, and as I say, the EOR sprite means that showing the sprite a second time will remove it. So that's what we're doing there. We're then continuing to test each of the directions, up, down, left and right here, and we're seeing if each one is pressed. If a direction isn't pressed, then we're skipping over the next piece of code. So this only runs if that direction is pressed, and this only runs if down's pressed, left's pressed, and so on. So here we're testing up. And what we're doing is we're checking the current position of the smiley and seeing if we're already at the edge of a screen. So here we're testing if we're already at pixel position y equals 0. If we are, we don't want to go up any further, because either we'll roll around or we'll end up corrupting some of the parent memory. So we're seeing if we are already at 0, and if we are, we're skipping over the subtraction command. This will move us up one line if we're in a valid position. So here we're checking if we're at the top of the screen. Here we're checking if we're the bottom. 160 is the height of the screen in lines, and our sprite is 8 lines tall, so we're just subtracting that in our comparison. So we're checking if we're at the bottom of the screen there, and if we're not, then we can move down, but if we are, we need to skip over. And we're doing the same for left and right here. So these are all of our boundary checks and also all of our Joypad direction checks in one go there. Once we've got to here, we're now in a position to show the sprite to the screen again, and that's exactly what we're doing. So this is the new position of the sprite before we removed it up here. We've now shown the new position, and so the final thing we're doing here is we've got a little delay. Now the Game Boy Advance is pretty fast compared to the 8-bits I'm used to, so we need to slow things down, and a very basic way of doing that is just to have a loop that doesn't really do very much. So that's what we're doing here, just a simple crude delay there, and then we jump back up to here for the next iteration, and that's how we end up with our moving smiley here. So that's what we do now. If the loop was shorter, if it was too short, we'd be moving at crazy speeds. You can see we're going very fast there. So we probably don't want to do that now. The other interesting thing is if I take away this first show sprite, well, you can see now we've got no sprite, and then if I start moving, well, you can see we've got a copy of ourselves, and that's because of those XORs. And you can see as they start to overlap, the second draw removes the first one, and that's the beauty and the curse of XOR sprites. I think XOR sprites are better than people say. I understand why people don't like them, but they're easy to get started with. You don't need to worry about redrawing the background when your sprite moves, or having a command that's remembered what was underneath and in a buffer and then drawing it back, things like that. So XOR I think is great to get started with. If you're watching this tutorial, you're probably really just starting out, and I think they're fantastic as a way of getting started, getting some stuff on the screen, and not having to fret too much about how to remove it and what to do if one sprite has moved and it's partially deleted another. Anyway, that's what we're doing today. That's the end of it. So you can go to my website and download the example code for today. As always, you can always get the source code for my examples from my website, and also the build scripts and hopefully the emulators and the whole lot. You can get all of it and compile this for yourself. And as I say always, if you manage to make something amazing out of it and become a massive success, well, best of luck to you. You don't need to worry about giving me credit to anything, because I'm sure you've earned it if you've managed to do that. Anyway, hope you get some use out of the source code, and I hope you have a lot of fun with it. If you've liked what you've seen, please hit the like button. If you like the videos, YouTube recommends them to more people. That's what I'm told anyway. And also, if you hit the subscribe, that would help me out, because I need to keep doing these. I need to know people are enjoying them. Otherwise, it would start to feel a bit silly me keeping making them. So if you subscribe, it would help me out, keep the motivation up. And I'm sure you'll see some more Game Boy Advance coming very soon. And I'll be actually doing this on the Nintendo DS next time as well. So if you want to see that, please subscribe along to see it. Anyway, thanks for watching today. Take care now. If you've enjoyed this video today, please consider supporting my content. It takes 20 to 30 hours a week to keep making these videos. It's basically all I do when I'm not doing my day job, and it's only through the support of my patrons and the other sponsors that I'm able to continue justify doing it, essentially. You can back me on Patreon. I post a weekly update with the latest work on the current projects I'm doing. You can see one here, and also the newest videos. There's a large backlog of videos that are currently only available to the patrons, although they will all be available to everyone later on. And also it's the backers who I ask when it comes to making decisions on how to change the content in the future, what new content to create and things like that. You can see there was recently a survey of the backers, so I can plan next year's content. As well as Patreon, you can now become a member of my channel on YouTube. There's a join button you should see just below this video. You can use that. YouTube backers get the same content as Patreon. I just post it through the YouTube interface instead of the Patreon one. It's the same content every week. Also, if you prefer, you can go to my Teespring store and you can get some Chibi Akuma's merchandise or some Learn ASM merchandise if you prefer, if that's how you would like to back me. Links for all three are in the description of this video below. Anyway, whatever you decide to do, I hope you've really enjoyed this video. Thanks for watching today, and goodbye.